All foiling means I multiply first, then outside, then inside, then last. And so when I multiply first, I get x squared. Outside gives me 4x. Inside gives me 3x. And then last gives me 12. So if I collect my like terms, I get 7x plus 12. So basically, x plus 3 times x plus 4 is equal to 7x, oops, sorry, I lied, not 7x, x squared plus 7x. And then if I factored it back out, I'd get x plus 3 times x plus 4. So factored form, non-factored form. That's fine. We don't really need this.
No, I don't get it.
Wow.
So in general, this is like the general form. If I had m and p instead of 3 and 4, I would have x squared plus mx plus px plus mp. Right? This would be mx and px, and this would be mp. So that's, in general, this is what the completely multiplied out form of this looks like. So the general form of factoring, well, let me take that one step further. These are both x's, so I could say m plus p times x plus mp. So what I have is, if I have that, that would factor to this. So what I'm looking for, this is a product, and this is a sum. So I'm looking for two numbers that when I multiply them, I get this number, and when I add them, I get this number. It's like a puzzle that has to be solved. And we'll talk about a couple different ways to do that. There are two ways to do this. We can use method 1, which I like to call the big giant X. I'm having trouble writing. Big giant X. No, just talking. Basically what I'm doing is I'm looking for two numbers that when I multiply them, I'll get 20. So this is for the multiplying. And when I add them, I'll get 9. Yeah, so that's what I'm doing. This is the big giant X. I go, okay, I need two numbers that when I add them, I get 9. When I multiply them, I get 20. Well, two numbers that I add to make 9, I multiply to get 20.
5 and 9.
4 and 5.
5 and 4.
And that becomes my factored form.
And that makes the
Plus
X.
4 plus 5. This, okay, big giant X only works really, really well when, see how this has no coefficient on it? That's when this works best. You can make it work if there's a number here, but it requires a couple more steps. So just the plain big giant X, just like where you can just do this, it has to have no number here.
Does that a giant X would then become a net?
No, it'll still be an X, but you just have some things you have to do ahead of time, and we'll go over that. I'll show you how. Method 2. Method 2 is to make a factor and sum table. And some people like the big giant X and some people like the factor and sum table. So I say factors
Is it a box?
of 20, not really a box, and then there's sum. So things that would add up to 20, okay, 1 and 20, well, they add up to 21. 2 and 10 add up to 12. 4 and 5 adds up to 9. Woohoo! This one matched. Okay, so you just like start listing factors of 20 or whatever number is here. and add them together, and when you get this number matches this number, you've found your factors. 5, no matter which of these I use. But does this make more sense to you? Are you able to quickly think of numbers that will multiply and add, or is this going to be better for you because doing stuff in your head like that is too confusing? It's a choice. So I'll do them both again. We have d squared plus 11x, no, plus 11d. Sorry. Should be, the letters have to match or you can't factor it. So if I do the big giant X, I want to add up to 11 and I want to multiply to 24. So can you think of two numbers that will multiply and make 24 and then add to 11?
3 and 8.
Yeah, 3 and 8. Okay, but if you can't think of that, that's fine. So I do factors of 24 and their sum. And I might say, okay, well 2 and 12, but that's 14. Yeah, 4 and 6, that's 10. And then I might go, oh, 3 and 8. And then that gives me 11. So I found them. So this will equal d plus 3, d plus 8. Now you'll notice that b and c on these are both positive, so I have plus plus. So that means these are both positive as well. So if these are both positive, these are both positive. Where'd any of that, darn it. Okay, so negative positive means negative negative. I'm looking for two numbers that when I add them, I'm going to get negative 8, and when I multiply them, I'm going to get positive 12.
Wouldn't that be 4 or something?
5.
It would be 1.
Negative 12 plus negative.
It'd be negative
No,
1.
plus
No,
4.
positive 1.
Negative 8.
Wouldn't it be positive 1? Negative 8 times positive 1?
No, I'm looking for two numbers that when I multiply them, I get a 12.
Oh.
So start thinking of things that multiply to make 12.
2 and 6?
2 and 6.
He's so smart.
So it's going to be x minus 2, x minus 6. And again, if you have a hard time with the big giant X, you could do factors of 12 and then the sum. And again, though, because these are negative positive, I want my factors to be negative, so I could say negative 4 and negative 3. Well, that would have given me negative 7. Negative 2, negative 6 will give me negative 8. Yay!
Ace. See?
You have 30.
So that means my numbers here are going to be negative and negative. And I want them to add up to negative 11 and multiply to make 28. Can anybody think of two?
Wait, what?
They multiply to make a 28, add to make 11.
7 and
7
4. I got it first.
Can I go to the bathroom?
Of course.
If your life's too short to make everything a competition. Life's too short to make everything a competition.
Okay, guys. Shh. So factors of 28, if the big giant X didn't work, we could start with 2 and 14, which would have given me 16. And then I might go, okay, 4 and negative 7, which would give me negative 11. I'm adding.
You're adding.
So, hold on. So I have one positive, one negative, so for 15. Okay, I want them to add to 15, negative 15. Sorry, add to positive 2 and multiply to negative 15. So I want one number to be positive and one number to be negative. And because this is positive, this needs to be the bigger number. Go ahead.
Positive 5 and negative 3.
Positive 5, negative 3. Because when I add 5 and negative 3, I get positive 2.
And when you multiply them, you get a negative. Negative 15.
When you think about it this way, it might help to make a difference table instead of a sum. So if I do 1 and 15, the difference is 14. 3 and 5, the difference is 2. And once I find the correct difference, then I pick which number to be positive or negative. So when C is positive, so this last term is positive, I'm looking for a sum. When C is negative, I'm technically looking for a sum, but it might help to think of it as a difference. Because I want one to be positive and one to be negative, so I'm looking for a difference between two numbers. So this would factor, and it would be x plus 5, x minus 3. And again, plus because of plus. So 5 is positive because the 2 is positive. Okay, if I'm doing this one, I want to add up to make -7, and I want to multiply to make -18. I want one positive, one negative. Guys, shh. Because this is negative, I want my negative to be larger.
He's hitting me.
So, are we in 3rd grade?
He started.
I did that in 4th grade.
Okay, so because I wanted this to be -7, I use a +2 and a -9. Again, if you need to, 6 and 3 has a difference of 3, 2 and 9 has a difference of 7. They match. If I want 7 to be negative, I make 9 negative.
Monkey.
So a quadratic equation is any equation of the form ax squared plus bx plus c equals 0 and a is not 0. So you have to have some sort of an x squared in order to be considered quadratic. If it doesn't have an x squared in it, it's not quadratic. It's just a regular linear equation. Now quadratics are not straight lines.
You don't say. It sounds like a box.
It's actually
4 lines?
a
or-
parabola.
It's a V.
A U. It's a U. So they'll look like this or this when we get around to eventually graphing them.
You know what helps is if you take your X.
Yeah, be very careful. It's not a V, it's a U. There is a graph that makes a V. We're not talking about that right now. We're talking about quadratics which make a U. So the first thing you need to do, you need to make sure it's equal to 0. So see how this is equal to 27? First I have to set it equal to 0, so I'm going to make that x squared plus 6x minus 27 equals 0. So what I did is I picked this up and I moved it to the other side and changed signs.
Stretching.
Okay.
It got really dark. You pulled my...
Once I've set this equal to 0, my second step is to factor. Okay? So I can do the big giant X, or I can do the factoring method. I'll use one on here and one on the other. So I'm going to look for two numbers that add up to 6 and multiply and make -27. So I have a -27, so I'm going to want a positive and a negative.
So would it be?
And I want my
9 and
larger
3?
number to be positive.
So 9 and -3.
9 and -3. So this factors to x plus 9 times x minus 3 equals 0. Once I factored, I set each parenthesis portion equal to 0, and then I solve. Okay, so I don't keep it in the parentheses. I just say x plus 9 equals 0, x minus 3 equals 0. Because when we did the zero product property, we said if two things multiply together and make a 0, one of them or both of them have to be 0. So I use that to say one or both of these is 0. Then I solve them. So I subtract 9 from both sides, so I get x equals -9. Or I add 3 to both sides. Yes, bless you. So x equals 3. So my solutions are x equals 3 and -9. Now, you'll notice I got two solutions. My exponent is a 2. Whenever I have an exponent of a 2, I'll either get 2 solutions or like one solution that repeats. Because sometimes you get one solution that repeats, it shows up twice.
X equals
2 and 2.
X equals -9.
Yeah, so I have 2 different solutions because I have a quadratics.
Negative 6 is put together.
0, this time I'm going to use the factor sum chart. Oh, except this time it's a difference because it's a negative 18. So things that multiply to make 18 are 2 and 9. They have a difference of 7. 3
6
and
and
6
3.
have a difference of 3. That's the one I want right there. This is it. Now, I want a positive 3, which means I want a positive 6 and a negative 3. Make sense?
Fin.
And then I'm going to take each of these and set it equal to 0. Okay, and then I solve each. Whoops, not plus. Sorry, minus 6. So x equals negative 6 plus 3 plus 3,
That's
x
0.
equals 3. So my solution is x equals 3 and negative 6. Of this. So Ling is designing a poster. The top of the poster is 4 inches long. That's the inspiration part. And this rest of the poster is, we have a width, and then the side is 2 inches longer than the width, and we want to know how wide does it need to be. So
we got a 4.
W plus 2 plus 4 is my length, right? Right? Because my length is all of this.
So with the second W
So
on
that
the
would be
bottom
W
being width,
plus 6, yeah, is my length. And W is my width, DTH. And area equals length times width. So we've got W times W plus 6 is equal to my area of 616. So I'm going to multiply this out first. So I get W squared plus 6W is equal to 616. And I have to set it equal to 0. So I move this over to here and change signs. Okay, now I have to factor this. I am looking for factors of 616 that will give me a difference of 6. Do you guys know those off the top of your head? No? Nobody? Factors of 616, you know those off the top here?
It is actually
Do I look like I know this off the top of my head?
No. Okay, so here's what I'm going to do. If I divide 616 in half, I would have 308. And if I divide that in half, I will have 154. And if I divide that in half, I will have 77. And if I take 77, that's 7 times 11. Okay. So I just want to double check my math real quick.
Oh wait, divided by 4, it's actually 154. 4 and 154 is also a factor.
Yeah, that's 2 and 77. Yeah, okay, that's correct. Okay, so I want to figure out how can I combine these numbers now to make numbers that will have a difference of 6. So what I have is I have 2, 2, 2, 7, and 11. This is the factored form of 616, right? Because I have 2, 2, 2, and then 7 and 11, because this was the same as that. If I multiply these together, that's 8. 8 times 7 would be 56.
Anybody have 2 quarters? I'll trade you for dimes.
Multiply these 3 together, I get 8. 8 times 7 is 56. Well, 56 and 11 do not have a difference of 6. If I multiply these together, I get 14. And then 11 and 4 would give me 44. That does not have a difference of 6. Do you see I'm just kind of like trying to combine numbers together? 7 and 4. And 4 is 28, right? And 2 and 11 is 22. Has a difference of 6. So I found it by using my primes. Did that make sense? Okay, so this is going to factor to W plus 28 times W minus 22. So one of these, this one, will give me W equals negative 28. Well, the width cannot be negative, so I can go ahead and take that one out. Because width can't be negative. So W minus 22 equals 0, which means W equals 22 inches. That is my width.